You're most welcome to Molten Heights Education Services. Today, we are continuing from our previous videos of differentiation, where we are differentiating from first principle. But today, we want to look at the formula, the general formula of differentiation. If you don't want to differentiate this from the first principle, what do you use, or which formula do you use to do that? So we are going to derive that formula, how it comes about. So suppose our function y is equals to x power n. We shall use what we already know. We add small increment in both sides and we continue. So it will be y is equals to xn, and we call this one our equation 1. So from there, we add small increment in y on the left-hand side and small increment in x on the right-hand side. So we shall have y plus delta y, which is equals to x plus delta x. Then it is raised to power n. So this one becomes our equation. Before we make it our equation 2, let's first expand what is it on the right-hand side. So on the right-hand side, what we have, since here we're having a power n, we shall use what? We shall use expansion by binomial. So if we expand this using binomial, we have x plus delta x power n. This is the same as what? So the first term in this bracket will carry the power n. So we shall have x power n, then plus this x. Now the power will keep on reducing. Meanwhile, this other term delta x, the power will keep on increasing. So we shall, to get the next term, it will be now what? N x n minus 1, then delta x over 1 factorial. Then plus, we shall now bring this power again down. We shall have n into n minus 1, n minus 1. Then we shall have x power n minus 2. Then we shall have delta x squared over 2 factorial. Then plus this expansion won't end there, it will continue. So here we are going to neglect the higher powers. So if we neglecting the higher powers, we shall have now this expansion of x plus delta x raised to power n being approximate to, since we are neglecting higher powers, we shall approximate. We shall have that to be equals as what? X power n plus n x n minus 1 delta x. 1 factorial is just 1. So if you divide by 1, it will not change this expression. So it will mean for our, what we have on the right-hand side, this side, we shall replace it with what we have here. So it means this equation will become y plus delta y is equals to xn plus nx n minus 1 delta x. So this equation will become our equation 2. So from there, what do we have? We shall pick this equation 2, then we subtract equation 1 from it. So we shall have y plus delta y minus y is equals to xn plus nx n minus 1 delta x. Then we subtract xn, x power n. So we shall see that what will cancel here, we shall have this y cancelling out with this negative y. Then this x power n will cancel with this negative x power n. So it will imply that our equation now will become what? Y, delta y is equals to this other, what has remained here is n into x power n minus 1 delta x. Now, if we divide through by delta x, we shall have delta y over delta x is equals to n x power n minus 1 delta x divided by delta x. So this delta x and delta x will cancel. We shall have delta y over delta x to give us what? N x n minus 1. So what we know that as what? As delta x approaches or tends to 0, then our delta y, or small increment in y over small increment in x, will tend to what? The y, the x from our previous video that we saw. So it means this delta y over delta x will become now dy dx. And since this side we don't have delta x, it will remain the way it is, n x n minus 1. Now, this is what we call the what? The general rule for differentiation. What does it mean? It means like if we had our function was y is equals to what? X n. So if you want to differentiate without using the process of first principle, ideally it would be what? Dy dx is equals to what we are observing, that we are seeing that this power n dropped down. So it will mean that we drop the power down, we have n, then x, the power, we reduce the power by what? By 1. So it will be n minus